Trig identities. A trig identity is an equation that is true for all values of the variable given. So I have here examples of two different trig identities. So what we're saying is that the left side would be equal to the right side for all values of x. Now you may have seen equations like this before if you did all your homework, big if. Now, it's not enough to just substitute in a value of x and see if the equation works. That's what you would have done before. For example, to see if sine 30 degrees divided by cosine 30 degrees is equal to tangent of 30 degrees. That's not what we're going to be doing this time. This time, we're going to be looking and trying to solve if this equation or any equation works for all values of x. So there are two trig identities that I will derive for you that will help us to solve other identities in the future. So remember, if I have a diagram like I have on the right, the adjacent side of my angle, so let's say that that's my angle theta, the adjacent side would be labeled as x for the x value, the opposite side is y for the y value, and r is the hypotenuse. Now the first identity is the quotient identity. So what I'm going to take a look at here is what is sine theta divided by cosine theta. Now using this triangle, and that terminal arm could be drawn in any quadrant that we want, and we'd still have sides of x, y, and r. Now sine theta, given this triangle right here, would be the opposite side over the hypotenuse, so that would be y over r. So that would be divided by cosine theta. Now cosine theta will be x over r. Now I want to actually divide these. Now remember from our first units, if you want to divide a rational expression or a fraction by another fraction, you multiply by the reciprocal of the second one, so we're multiplying by r over x. Now what you'll see happens here is the r's will cancel out, and we're just left with y over x. So sine theta divided by cosine theta is equal to y over x. Now looking at this triangle though over here, y is the opposite side, x is the adjacent side. So y over x is actually the same thing as tangent theta. So this tells us that sine theta divided by cosine theta is equal to tangent theta, and that's for any angle theta. So I don't have to draw a specific angle. Wherever we draw that angle and terminal arm, sine theta over cosine theta will be equal to tangent theta.
Hello, my name is Arnold. I will be describing to you the next identity called the Pythagorean identity. We are going to start with sine squared theta plus cosine squared theta, and we will see what that adds up to. Now, given this triangle, just like that puny Mr. Kovalcheski showed you before, sine squared theta would be y over r squared plus cosine squared theta would be x over r squared. So now we want to simplify this, and we know that when a fraction has an exponent, the exponent applies to the numerator and the denominator. So y squared over r squared plus x squared over r squared. Now we have to add these two fractions, and as we know, we have to have the same denominator. The denominator is already r squared, so the numerator, I can add y squared plus x squared over r squared. Now looking at the triangle, it is a right triangle, and as we know with a right triangle, x squared plus y squared will be equal to r squared. So instead of y squared plus x squared, I can put r squared over r squared. This is why it's called the Pythagorean identity, because we are using the Pythagorean theorem. Now r squared over r squared is equal to 1. So for any angle theta, sine squared theta plus cosine squared theta is equal to 1.